Edexcel Decision 1, Linear Programming 3, Using the Simplex Method. So we're going to look at solving a linear problem with 3 variables using the Simplex algorithm. And to do this, we need to rewrite it in augmented form. So we rewrite P so that P take away 6x, take away 8y, take away 10z equals 0. Then we need to introduce slack variables to our inequalities to get 2x plus 3y plus 2z plus s1 equals 10, and then we need to introduce s2 such that x plus 3y plus 2z plus s2 will equal 8. And then don't forget we need to add the trivial inequalities. S1 is greater than 0, S2 is greater than 0, and that's it. So now we're going to set this up in an initial Tableau. So don't forget the objective function always goes along the bottom row. Objective row becomes -6, -8, -10, 0, 0, 0, and the basic variable is P. So then we look at the other two constraints, the other two equations. So the first one will give us the row 2, 3, 2, 1, 0, 10. And the basic variable at this stage is S1. And the second equation will give us a row of 1, 3, 2, 0, 1, and 8. And the basic variable here is S2. Remember that at the start, x, y, and z are all 0 since we're starting at the origin. So next we need to identify our pivot element in order to perform the simplex algorithm. So we look for the smallest negative element in the objective row, and that's 10. So Z is our objective column, and then we perform the ratio test. So row 2 becomes the pivot row, and 2 becomes the pivot element. So we need to reduce this 2 to a 1. So we need to halve row 2, first of all. So we've got a half, 1.5, 1, 0, a half, and 4. And since this is our pivot row, and 2 is in the column Z, Z now becomes the basic variable. So then we use this new row 2 to reduce all the other elements in column Z to 0. So we use the operation row 1, take away 2 lots of the new row 2. So we get, and our basic variable remains S1. So then to reduce row 3, we need to do row 3, add 10 lots of the new row 2. So we do -6, add 10 lots of a half. So that's -1. And we get 7, 0, 0, 5, and 40. And our basic variable stays P. Okay, since we still have a negative element in the objective row, we need to perform another iteration. So we know the objective column this time is going to be x, so we need to perform the ratio test again. So we get 2 divided by 1 is 2, 4 divided by a half is 8, so this means that 1 is our pivot element. So now that we've identified our pivot element, have a go at filling in have a go at doing the second iteration yourself. So we didn't have to do anything to the row that contained the pivot element since it was already 1. And then we used that row to reduce all the other elements to 0. So our operations were row 2 take away a half of the new row 1 and row 3 add row 1. So now we can see we have finished our algorithm and we don't need to perform any other iterations since all elements in the objective row are non-negative. So we're now going to look at interpreting the table at the end of each stage. So to find a basic variable, we need to find a column that contains a 1 and lots of zeros. So for the initial table, we can see that our basic variables are S1 and S2, and all the other variables are non-basic. So X, Y, and Z are all equal to 0. We can see from the table that S1 equals 10 and S2 equals 8 and P at this stage is also 0. So then after our first iteration we look for basic variables, and the basic variables this time are Z and S1. So our non-basic variables are X, Y, and S2, which are all equal 0. So our table tells us that Z equals 4 at this stage, and S2 equals 2 at this stage. And it also tells us that our objective function P is equal to 40. So we know that 40 is a valid solution, but we also know that it's not an optimal solution. So we're going to look at our final tableau, and our final tableau tells us that the basic variables are X and Z, so all other variables are 0. So we've got Y is 0, S1 is 0, and S2 is 0. So we know from our table that X is 2, and Z is 3, which gives us an optimal solution of P equal to 42. So this concludes our section on using the simplex method.